All right, today we are looking at our next conic section, parabolas, and we have looked at parabolas in the past, in the fall, and we only looked at vertical parabolas that opened up or down, but parabolas can actually also be horizontal, opening left or right. So first, let's talk about what defines a parabola. Remember, a parabola is when I am taking that vertical plane through my cone, and it is all the points that are an equal distance from a focus and a directrix. So that D1 is saying the distance from the focus to the point, and D2 is the distance from the directrix to that point. And so for all points on my parabola, those two distances are the same. So let's talk about some important pieces and terms for both vertical and horizontal parabolas. The vertex, you should be familiar with that. That is either your lowest or highest point of your parabola. I'm going to just abbreviate that with a V. That's your vertex. And then this point inside the parabola is your focus. I'm just going to abbreviate that with F. And then for this vertical parabola, I have a horizontal line that is outside the parabola, and that is my directrix. And then I also have an axis of symmetry, and for a vertical parabola, that is a vertical line. And then the distance between the vertex and the focus is a value P. And then the distance between the vertex and the directrix is negative P. Okay. And then a horizontal parabola has all of the same things. We still have a vertex. We have a focus inside the parabola. Our directrix, however, is a vertical line. And our axis of symmetry is horizontal. From the vertex to the focus, that is still P. And from the vertex to the directrix is negative P. So, as I've said, the focus always lies inside the parabola, and the directrix is outside. And our directrix and our axis of symmetry are perpendicular. And then the vertex is the absolute value of P away from the directrix. And we say absolute value because the sign of P, being positive or negative, tells us what direction the parabola is opening. So let's look at standard form for our equations. And this is actually not what we have referred to as standard form. In the fall, we did vertex and standard form for parabolas. So to make a distinction, we are going to call this one transformational form. This is a special form. So for a vertical parabola, meaning it's opening up or down, we have x minus h squared equals 4p times y minus k. So when p is positive, it opens up, and when p is negative, it opens down. And then for a horizontal parabola, the x and the y are swapped. So I have y minus k squared equals 4p times x minus h. And when P is positive, we're opening to the right, and when P is negative, we're opening to the left. So HK is the vertex of my parabola. Again, P helps us determine the direction of the opening, and then the distance from the vertex helps us find the focus and the directrix because it's P away. And so we are going to now practice graphing some parabolas with all of that new information we have. So starting here with number 1, the first thing I want to determine is this a vertical or horizontal parabola? And because I have x squared, that makes this, a vertical parabola. And my vertex is at 0, 0 because I have nothing being added or subtracted to my x or my y, so that makes that pretty easy. Now this number 8, that negative 8, that is what is equal to 4p, which tells me that p equals negative 2. Now, because P is negative, that means that this parabola is going to be opening downward. So to graph this, I'm going to start with my vertex, and then I'm going to plot my focus and my directrix. So P being 2 means that I am going to go 2 away from my vertex to get my focus. And because this parabola is opening downward, my focus is going to be below the vertex. So I'm going to go 1, 2. There's my focus, and those coordinates are 0, negative 2. And then I'm going to go the opposite direction up 2 to plot the horizontal line that is my directrix. And the equation for that directrix is y equals 2. And now I'm not super picky about how wide or narrow your parabola is. I just want to make sure that all of these pieces are in the correct location and it's opening the right way. So as long as it's opening downward, I don't care about how wide or narrow it is. And then lastly, our axis of symmetry is a vertical line here, and it is actually our y-axis. Easy enough. Okay, let's look at number 2. This one is going to be a horizontal parabola because I have y squared. Again, my vertex is 0, 0. And then the 6 is equivalent to 4p. So that's going to help me determine what direction this is opening, as well as finding my focus and directrix. So if 6 is equal to 4p, that means p is equal to 3/2 or 1.5, however you want to write it. And that is a positive number, so that means that this parabola is opening to the right. So I'm going to graph my vertex at 0, 0. And then my focus is going to be 1.5 away to the right because it's inside my parabola. So that focus is 1.5 or 3/2, 0. And my directrix is going to be 1.5 in the other direction, and this time it's going to be a vertical line. And the equation for that line is x equals 3/2 or 1.5, however you'd like to say it. There's my parabola opening to the right. My axis of symmetry is the x-axis here, so that is along the line y equals 0. Let's keep practicing with our graphing. On to number 3. I now have a vertex at another location, and the x-coordinate is with x, the y-coordinate is with y. So that vertex is at 3, 2. So you can go ahead and graph that if you'd like. And because my y is squared, that tells me that this is a horizontal parabola. If -4 is 4p, that means p is -1. If p is negative, that means that this parabola is going to be opening to the left. So starting at my vertex, I need to go 1 away to get my focus and 1 away to get my directrix, which is going to be a vertical line. There's my parabola. I'm going to go ahead and fill in. My focus is at 2, 2. The directrix is the line x equals 4. And my axis of symmetry is a horizontal line that my parabola is symmetrical across, and that is at the line y equals 2. Okay, last one for graphing. On to number 4. This is a vertical parabola. My vertex is at -1, -2. And 14 is equal to 4p, which means p is 7/2 or 3.5, however you want to write it. P is positive, which means it's going to be opening upward. So there was my vertex. So I'm going to go up 3.5. 1, 2, 3.5. There's my focus, and then down 3.5. And there's my directrix. This parabola is opening upward. And then my axis of symmetry is this vertical line here at x equals -1. Okay, moving on, we are going to look at a little different type of problem now. Again, equation for a vertical parabola and a horizontal parabola. And P is the distance from the vertex to the focus and the directrix. So we're going to first practice looking at graphs and writing the equation from the graph. So let's look at number 1. This is obviously a vertical parabola that is opening upward. So I know I'm going to use my vertical parabola equation. And I can locate right here my vertex is at 0, 5, which helps me find h and k. And the last value that I need to find and identify is p. And remember, p is the distance from the vertex to the focus and from the vertex to the directrix. What I'm given here is the focus, and those 2 points are 2 apart. So p is 2, and I know p is going to be positive because I'm opening upward. So I have h and k. I know p is 2. Let's plug that into our vertical parabola equation. X minus 0 is just x, so this is going to be x squared equals 4 times 2 is 8 times y minus 5. And it's just that easy. Let's move on to number 2. This is a horizontal parabola that is opening to the left. So before I even know what P is, I know it has to be negative because of the direction this parabola is opening. Let's identify right here. This is my vertex. It is at the point 3, -2. And then if I can find how far apart the vertex and that focus is, and that's 5 units, that tells me P is going to be -5. And again, it's negative because of the direction. So now I can plug in all of this information to my horizontal parabola equation. So y plus 2 squared equals -5 times 4 is -20 times x minus 3. Okay, we're going to do 2 more like that. On to number 3. This will slide up. This time I'm given the parabola and the directrix. So this one again is horizontal and we're opening to the right. So whatever P is, it has to be positive. My vertex is located at the point -6, 1, and it is just 1 unit away from the directrix. So P is 1 for this parabola. So horizontal parabola, P is 1, that's my vertex. So y minus 1 squared equals 4 times x plus 6. Okay, last one for graphing. Again, parabola and directrix. This one is vertical opening downward, so I know P has to be negative, whatever it is. My vertex is right here at the point -4, -5. And my distance from that vertex to the directrix is 10. So P is -10. Again, it's negative because we're opening downward. So there's my vertex, that's P. Let's plug it into our vertical parabola equation. X plus 4 squared equals -10 times 4 is -40 times y plus 5. And that is it for part 1. Make sure you watch the next video to catch the rest of the notes.